Today is about the energy transition, but before we tell what we are doing, do we know why we are doing that? I think this is the key. We have seen in the short video, our target is to decarbonize, to come to a temperature rise by 1.5 Celsius degree by end of the century. If we don't do, what will happen? Well, we are going to a catastrophic situation which will be around 3.7 degree of temperature rise. Of course, we don't want to do that. Just to keep an idea on emissions, so you can see per year there are emissions per gigaton, means billions of tons. And here we would like to show how we can step by step reduce these emissions. First of all, we are very proud, also as Innomotics, in the last 3 years, from 2021 to 2023, we have avoided more than 85 megatons of emissions. Of course, this is nothing almost to the gigatons, but this is where we have to step, and this is where we need to take this step. And how we do that? I mean, we do have also many applications, but also for the future. For the future, we want to step more in the battery production, in hydrogen production, hydrogen compression, carbon capture, energy storage, many other new markets emerging now, which will be the markets of the future in 5 to 10 years. And this is where we have to work now. Concretely, some examples. The first one is a cement plant in Vietnam, just working on leveraging the energy efficiency. We have reduced the CO2 emissions by more than 7,000 tons. And here, you can just, on your existing plants, retrofit your motors, take higher efficiency motors, replace motors with a system, motors plus drives, which will give you also some saving on energy. So it means the less you use of the energy, the less you are emitting a dioxide carbon. A very drastic one, with a Repsol on a refinery. So here we replaced existing turbine, gas turbine, by a full electric solution. Means motors and drives. And here, of course, the impact is much bigger. We speak about 68,000 tons of emissions avoided. So these are examples on the concrete projects. But when we look on the motors, and I will tell you why motors are crucial in the decarbonization. So when we look what we have done with the motor IF4 to IF5, means higher energy efficiency, then we have also improved the energy efficiency and means reduced the dioxide carbon emissions by more than 23%. So here, this is also a big impact, but there are many applications, but also the portfolio is also a big contributor to that. And here, when we will see on the energy transition, we will talk about hydrogen, dioxide carbon. So what is the role of the motor in there? Well, very basic. Whenever you need a pump, a fan, a compressor, you need a motor. That's why actually this is a huge market also for Innomotics, and here we have the right portfolio in our hands. A concrete example on hydrogen. So you can see the different types of motors used in the different size of the hydrogen plants, starting from the smallest to the mega hydrogen plants. And here you will see two types of motors that we have called low voltage, which is mainly the voltage level below 1000 volt, and then anything higher than 1000 volt is called high voltage. And this all in our portfolio as Innomotics, where we took the legacy from 100 years of experience from Siemens. Concretely, on the green hydrogen. So before, green hydrogen is getting hydrogen from water. To do that, you need a conversion from AC to DC. This is where we have a rectifier system. This is also in our hand, and we have a rectifier experience for more than 60 years. And here, a technology that we know very well. We supply the rectifier with a transformer, a skid or e-house, where we have a turnkey approach on supplying power to electrolyzer. But before getting to the electrolyzer, water has many minerals inside, which is the water we drink. So to make green hydrogen, you need pure water. Means the water purification part, this is where also you have many pumps which will treat the water to remove the different minerals in the water. And of course, once you have hydrogen as gas, it's difficult to transport. You need to compress it. And this is again where we will use our motors, but also our drives to compress the hydrogen from gas to liquefy it and then to transport it or to store as well hydrogen. Green hydrogen. Of course, this is what we need more. But currently, when we see the green hydrogen means the electricity to power the rectifier or the electrolyzer should be from renewables, means PV or wind or hydro. And this is already, I would say, a way to do it. But sometimes it's also costly. That's why, unfortunately, many of the green hydrogen projects are delayed or the final invest is not happening. So currently, what's happening? Blue hydrogen. And blue hydrogen is a completely different way to get hydrogen. And you get hydrogen from gas, from natural gas. And with the cold steam reforming reactor, this is where you can break the molecule of methane or gas into hydrogen, but the drawback is you get also dioxide carbon. So if you capture this carbon, then you have a blue hydrogen. If you don't capture it, it becomes gray. And this is a very strange thing, that you generate a clean energy and at the same time you will emit dioxide carbon. That's why gray is an absolute disaster, but unfortunately currently most of the hydrogen is produced in this way. So blue at least keeps the dioxide carbon emission, where you have some licenses which can capture the dioxide carbon up to 90%, and you get your hydrogen with less emissions. I mean, besides hydrogen, you will hear that dioxide carbon becomes also a key element in our world. In the overall energy world, dioxide carbon will be a key element. So, I mean, if we want or don't want, we have it. So we have to get rid of it. So, and you will see that, of course, in oil and gas, in refineries, but also in cement plants and metal plants, that not only due to energy consumption, due to the process, you will have emissions of dioxide carbon. So, and here, carbon capture is a way to avoid these emissions to go to the atmosphere. And of course, again, you see here the SMR. And in all this process, again, as mentioned, you need pumps, fans, compressors, and this is where we have our portfolio. And then once you have, again, captured the dioxide carbon, it's a gas or semi-fluid, you need to compress it. And when as a liquid, when you can transport through pipeline and store it on a reservoir underground, or you can reuse the dioxide carbon to make polymers, e-fuels, and then also use dioxide carbon in combination with hydrogen to create methane that you can reuse again. So this is actually a key element in the overall net zero approach that many companies have. Doesn't mean that they don't emit, means that whatever is emitted will be captured and reused. In this approach, what we see is that oil and gas companies are very much advanced. And why? Because this is a technology which is well known to them. And when we see the carbon capture, actually it's very similar to oil and gas. You have the upstream part, which is the capturing, where you have, of course, our motors and drives. And then the transport part, compression, which is usually midstream. And then storage or reusage of dioxide carbon is then the downstream part. And here, for each of type of pumps or compressors, when you have the, let's say, depending on the size, you can have our motors from us and also drives if necessary. So this was all, I will say, to reduce, let's say, the emissions. But there are also other ways to completely get rid of dioxide carbon. And this is, of course, an amazing impact. Very good example is replacing gas and steam turbines by full electric system. You can see on the upper side how a traditional steam turbine is working, where you have a machine which is driven by a turbine run by fuel. And fuel is even more emitting emissions, dioxide carbon, than gas. And also, you need a lot of water. You have to create the steam. And this is a very polluting solution. And most of the refineries are currently running with steam turbines. So what we do now, we take complete part and we replace with a motor, drive, transformer, switchgear, full electric solution. If your electrical system is powered by renewables, you have zero emissions. Means you cut any emissions. And this is what we see that in the last years, it's really ramping up. And this is what many of the refineries, but also existing plants on cement or steel plants, where we need to replace this existing high pollution solutions. And to do that, it's not that easy. The motor is a high-speed motor. So we speak about up to 16,000 RPM. So this is the linear speed of a supersonic jet. The precision of the motors, we speak about micrometers. The force you have, this is a force comparable to many trucks. And this technology, we have it in our house, and we have many references in that. And then imagine, with speed and with power, you have to run smoothly. You have to be running without any vibration. And this is where we have also the expertise in our house with our drive solution. We are able to control the system without damaging the existing mechanical parts. Another approach also, we need to think innovative to save the energy. This is an example of so-called compressed air energy storage. Here, it's a very simple principle, actually. When you have excess of energy from PV, for example, or wind, or when energy is at low price, you can use the motor to heat the air in a reservoir and compress it. This is kind of, let's say, energy source. It's completely natural. There's no battery there. And then you need energy. When you can release this air to run a generator, and this generator will, of course, produce electricity. So this is a very smart way to do it. And currently, we are manufacturing the biggest motor ever, 105 megawatt. This is the biggest motor ever being produced. The previous one actually was also from us with 78 megawatt. So we have broken our own record and we go to the over 100 megawatt of power. And this is, of course, also giving ideas to new technologies to be innovative, to find new solutions with low or zero carbon emissions. A final example. Also, this is a very simple principle. I believe you all have a refrigerator at home. The refrigerator is taking the heat from inside and giving to outside. Here the concept is the reverse process, but we take the heat from outside, bring it inside. And to be able to do that, you need a cycle of a liquid compressed, and you go through different processes as well, and you get actually this heat from outside to inside. You may say, oh, in Germany, in winter, it's cold, but we still have energies there. Even at 0 degrees Celsius, you have 270 Kelvin, so it means some heat energy is available, and we can do that. And in combination with a water treatment plant, for example, water will, if it's not frozen, will have some energy there, and we can take also this energy to bring it to inside. And this is a market that definitively we see growing in the next years. And here again, to be able to make it in a also efficient way, reliable way, when we have our portfolio with our motors and drives. To recap, first of all, on the left side, we know that there is a growing energy demand. The Earth population is increasing, and we need energy. We know that we need more renewables, but unfortunately, it's not enough. So we know that there will be a need for gas in the next decades. So we need to handle this gas and oil to avoid to get to a worse situation. Second topic, sustainability. And here, NZE means net zero emissions. And you see a lot of companies making very bold statements. We will be net zero neutral. We will get by 2030, 2035. Fact is, it's not about the year. The fact is really to understand how it works. We as Innomotics, we see that our own contribution from our factories to the carbon footprint is around 1%. Means, even if we have completely full green factories in Germany, we won't be able to reduce our carbon footprints. So here the key is the supply chain. And the supply chain means we have to work on our suppliers who have to work on their suppliers. And mainly, of course, on a motor, you have aluminum, you have iron, you have steel. And this is where copper, of course, you will have to work to get this raw material clean. Decarbonization, as mentioned, capturing the dioxide carbon is key. Reusing is another big factor. But when hydrogen, ammonia, there will be many new other, let's say, way to decarbonize. Also, another point is electrification. Whenever possible, to remove gas-emitting or dioxide carbon-emitting solutions by full electric systems. And this is where we have our power supply solutions, like we want to power the electrolyzer for hydrogen. Energy efficiency, it's clear. So when it's also it's not only about having new ideas, but also leveraging, improving. Any percentage of energy saved is helping us. And what we do, of course, as Innomotics, for all our future products, so from a design, we think eco-efficient. We have to make our motors, our drives, our overall solutions more eco-friendly. Finally, also business. Carbon tax is being implemented in many countries, and the tax will increase more and more. And by 2028, there will be significant impact. So it means if you don't want to pay carbon tax, you have to work now to remove your solutions, or let's say existing approaches with dioxide carbon emissions. You need to move now to a more clean power supply. And then, of course, if you want to do business, also, then you have to be able to give a proof of your carbon footprint, and you need to be able to show that you are taking concrete actions to reduce your overall carbon footprint. So, who's convinced that every one of us can contribute to that? So please, can you stand up? Stand up, please. Whoever is not convinced can stay. Then, if we are ready, let's take this step together. Thank you.